Yo, 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 Math by the Moon, back with another video. I'm going to help you out with exponent rules involving rational exponents today. So, you ready? So, the first thing I want to share with you is a document that has some really helpful powers to know, because when you have to evaluate powers, if you don't have a calculator, it's easy to figure out. So let's say, I think in the last video, I was doing a problem that was the fifth root of 32. The fifth root of 32. So I'm trying to find 32 on this page, and whoop, right there it is. And the fifth root of 32 would be 2. So you can kind of use this table here to help you. So I'm stalling a little bit. So if you needed to like screenshot this and save this, there it is. And I just found this on Google. So you can always Google it. I want to do a few examples involving the exponent rules, and this is another screenshot from a Google site that you can just simply see these exponent rules. We've used them before when they're basic integers. When you add, when you multiply, when you subtract, the reciprocal power for the negative exponent rule, and so on. So if you need any of that, there it is. The examples I want to do with you are right here. So this first one, it's a multiplication question, but it also has a power of a product. So using order of operations, the first thing you technically have to do is take care of your exponent, this 1/2. And remember that the 1/2 needs to be distributed to every exponent inside this quantity. And what this 1/2 power really is a square root. So when I bring that in over here, and I'm thinking about it in terms of what's the answer to the square root of 4, as opposed to thinking of it as 4 to the 1/2. The square root of 4 is 2. And I will also use the rule for power to a power here to multiply the 4/7 times the 1/2. So this will be x to the 4/14, which if I want to reduce that, 4/14 would be 2/7. I should have used some cross-factoring rules there. Then this whole quantity here with the 3/2 x to the 2/5, I'm going to copy it back down because we really didn't do anything with it. And then I'm going to continue on my way here. Now I have a multiplication problem. So one thing is always true about any type of math problem. Numbers, or in this case coefficients, you always give them whatever the treatment is. Meaning in this problem, it's a multiplication problem. The treatment for the 2 and the 3/2 is going to be multiplication. They're not exponents, so they're not involved in this exponent rule thing. Kids will sometimes try to add these two numbers because that's the next step for the exponents, but these are just regular numbers. You give the regular numbers the regular treatment, which is multiplication. So 2 times 3/2 is 3. And then these exponents right here, we're going to add those. So we'd have x to the 2/7 plus 2/5. So in order to add those, we have to get a common denominator, which means we'd be going all the way to 35s, right? So 35. So if I change this to 35, that'll be 10/35, right? And if I change this to 35, that'll be 14/35, which would give me 28/35. Or 24/35, excuse me. And that right there would be the final answer. Going back to the beginning, the reason why we had to take care of this exponent first is because of order of operations. You do exponents before you can multiply, right? So before we could take care of this dot, we had to take care of the exponent first. Second example, and so this would be our final answer there. Second example, the first thing we're going to talk about is the same thing we did up here with the 2 and the 3/2. They're just regular numbers. So we give them the regular treatment, whatever's between them. And up here it was multiplication. Here, between these two numbers, -12 and 15, is a fraction bar, meaning we're going to divide or reduce in this case. So if I reduce both of these by a 3, I'd have -4/5. I'm going to shorten up that bar a little bit, because the next thing I'm going to do is I'm going to use the exponent rule for a quotient. When we have a quotient, usually we subtract the top amount minus the bottom amount, right? The top is usually the bigger amount. So, and that doesn't always happen because sometimes there's more of that variable in the denominator. So here in this case, we'll just write it out as x to the 4/7 minus 3/4. And then we have our y's, which is -1/2 minus, I'm going to put parentheses around this because it's looking a little funky, 1/5. So I have this new problem now, and it's all multiplication between, because what we're doing is this exponent rule. We're going to clean it up, getting a common denominator to subtract. Here I need these to be out of 28. So out of 28, I'd multiply this one by 4, which would make 16, minus multiply this one by a 7 would be 21. So I'm going to have -5 -5/28. And then over here, I need to make these out of 10. So this would be -5/10 minus 2/10, which would be -7/10. And now the only thing that's left to do, and in math class, we don't like negative exponents. It's one of those things where we just can't quantify it properly. Like when somebody says, write out 3 squared, well, we know what that means. It means 3 times 3. But when we say write out 3 to the -3, we have to use the reciprocal power, the reciprocal rules for negative exponents. So to make this better understood in math class, if this answer isn't there, and like let's say it's a multiple choice question, what they'll want you to do is take these and move them underneath with the 5. So we'll make this one big fraction, -4/5, and x to the +5/28, and y to the +7/10. So that would be your final answer with that, okay? So what we did is we moved this exponent, which was negative, down to the denominator to make it positive, along with the 7/10, which was negative as well. Notice how these coefficients, the -4 doesn't move to the bottom. The -4 is just a regular number. I'm going to reiterate the fact that regular numbers get the regular treatment. Just because something's negative number-wise doesn't mean you move it. If it's a negative exponent, those are the ones that get switched. So you take the base and the power and move it to the other side of the fraction bar. If it's negative in the bottom, you can move it to the top. If it's negative in the top, you can move it to the bottom. And when you do that movement, it makes the exponent positive. And that's where we can actually figure out like what it means then. Like I said, you know what 3 squared means. It means 3 times 3. But you don't really understand what 3 to the -2 means until you move it down to the bottom, and then it becomes 1/3 squared. So that's why the negative exponent rule is what it is. It helps us understand the actual quantity that we're getting. So hopefully this helps you with your exponent rules a little bit. Don't forget common denominators for fractions when you add or subtract. And again, if you need that little cheat sheet of powers, that might help you. Flip back in the video to that cheat sheet and take a screenshot. Hope that helps. Later.